Everyone, welcome to Saurabh Sir's classes. I'm Nirupam and today I'll be talking about the solo growth model. The solo growth model is a model which is an exogenous growth model, and it is also considered as a benchmark growth model because all of the growth models that are being developed or discussed have been developed by relaxing the assumptions that are made in the solo growth model. Okay, so to begin with the solo growth model, we start with the production function y of t, that is output produced in an economy at time period t, which is nothing but a function of k of t, a of t, as well as l of t. Okay, so this is nothing but a function of these three factors, that is kt, at, a of t, and l of t. Now, what does kt actually mean? Kt actually means that it is k of t actually means that it is stock of the capital at time period t. At actually denotes the level of the knowledge accommodation at time period t, or the effectiveness of labor at time period t. And L denotes the amount of labor, the number of the labor that have been employed at time period t in the economy. So this is nothing but, so the output is dependent on these three factors. Now we can multiply these two factors, that is a of t as well as l of t, to get al of t, which is nothing but the effective labor force in the economy. So it is the effective labor force in the economy. So then we can rewrite this function as follows, that is f of k of t al of t. Okay, now with this assumption as well as with further assumptions, what we will be finding in the solo growth model, that over a period of time y by k will approach a constant, that is the ratio of output to the ratio of capital stock at that point in the economy will be approaching a constant and will not fluctuate greatly or will not vary greatly. Now, one of the other assumptions which is being made in the solo growth model is that these factors of production exhibit constant returns to scale. That means if we are changing these factors by number c, then the output will also change by number c. That means f of c of k of t equal to c of al of t will lead to this, that is f of k of t al of t, which is nothing but c of y of t. Okay, now if you would like to study this solo growth model, then we can also change this production function into its intensifier to do this. So we'll be taking c as a by a 1 by al. That means we can rewrite this expression as follows, that is yt divided by al of t al of t equal to so we can rewrite this expression as follows, that is y divided by L is equal to 1 by L f of, okay, so y by L equal to 1 by L f of k al. So we can write this as f of k by al, which is nothing but y by al equal to f of k by al 1, or y equal to f of k by al, or f of k. Okay, That means we can now write this. Sorry, we can now write that the output per unit of effective labor as a function of capital per unit of effective labor. So when we will be studying the properties of these variables that are included in this production function, that is the inputs K, L, A, as well as the output, we will be studying them in terms of the small k, that is the capital per unit of effective labor, rather than considering all the individual variables. So when we would like to check about the output per unit of labor, so rather than considering these two factors separately or these two variables separately, we will be studying the properties of A of f of k, okay, and accordingly we will be doing similar such studies. Now there are certain properties of this function, that is f of small k. So we are assuming, applying Inada's condition, we can say that when k tends to 0, that means small k tends to 0, then on limit f prime of k, that is the first partial of k, will tend to infinity, and when k will tend to infinity, then at the limit k tending to infinity, f prime of k will tend to 0, okay. And using further the factor, that is f of k is always greater than or equal to 0, we can now draw the graph of the output per unit of effective labor and that of the capital per unit of effective labor as follows. Okay, so this is what the graph of the function for the output per unit of effective labor will look like when we are applying the Inada's condition, that is limit as k tends to 0, f prime k will tend to infinity, and at limit at k tends to infinity, f prime k will tend to 0, and also f of k is always greater than or equal to 0. Okay. So using these assumptions and the Inada's condition, we get the following graph of the output per unit of effective labor. Now we will now be discussing a special function, that is the Cobb-Douglas production function, to study the see how these assumptions that have been used. So now using the properties, using the specific production function, that is a Cobb-Douglas production function, we can see how applying the assumptions that we have made for the solo growth model production function, the output per unit of output per unit of effective labor will look like. So let's say the Cobb-Douglas production function which also exhibits constant returns to scale like the solo growth model production function which I have assumed, and it is of the following structure, that is f of k of al is equal to k to the power alpha and al to the power 1 minus alpha, where alpha is nothing but a parameter of this production function. It's an exogenous parameter of this production function. And when we are actually changing, let's say, the factors by factor k, then the output also changes accordingly. Okay, so we can see that these production functions exhibit constant returns to scale like the production function solo growth model. And now if you would like to see in its intensive form, whereby variance is equal to 1 by AL, and let's see what we get. That is f of k by AL is equal to 1 by AL. Okay. Okay. Fine. So this is how the Cobb-Douglas production function will look in its intensive form. Now, if you would like to look at the marginal functions of this production, marginal, I mean the first differential, that is the marginal productivity of capital per unit of effective labor, then you can see that f prime k is nothing but lambda of alpha minus 1, and taking the second order differential we get this as follows: lambda alpha, yes, lambda, okay, alpha minus okay, so which can be written again as follows. Because in Cobb-Douglas production function, lambda is greater than 0 but it is less than 1, and hence this term is a it will be negative, so negative multiplied with two positive terms, that is lambda, and k raised to the power lambda minus 2 will always be less than 0. So just like so we can see it is exactly giving and demonstration. It is exactly giving a demonstration of the properties of the production function which we take in the Solow growth model in its intensive form. Now we would like to study the properties of these variables as well as the inputs which are used as an inputs in this production function in greater details. So given the initial values of, so there are three factors of production, that is A, L and L. Now we will be starting first with these two factors of production, that is A and L. Now given the initial values of both A and L, they will be growing at a constant rate such that for AT, A dot T and L dot T, we can write this as follows: G of T, N of T, where G and N are exogenously given. And A dot T or L dot T is nothing but the derivative of these functions with respect to time t. Now the proportionate change in a variable over a period of time will be giving its growth rate. That means A dot T by AT will be giving the growth rate which is nothing but equal to 0, G, and L dot T by LT will give nothing but the growth rate of labor over time, which is nothing but N. So both this effectiveness of labor, knowledge accumulation as well as the labor force is growing at a fixed rate, G and N respectively, over time. Now using further the result, that is the growth rate of any variable is equal to the rate of change of its natural log over time, we can write both these functions as follows. That is, A dot T is nothing but del log of AT dt, so it is nothing but del, using the chain rule, del log of AT by d of which is again A T into A dot T. So similarly for LT also we can write as follows: L dot T by LT is nothing but 1 L of T into A dot T. Now we can write these two expressions as follows. That is, so we had got the initial of this expression, that is A dot T equal to GT and L dot T equal to NT. Okay. So now using these expressions, that is of the growth rate of effectiveness of labor as well as the growth rate of capital and growth rate of labor, as well as these two expressions, we can again write the following two expressions, that is log of AT equal to log of A0 plus GT, then log of L of T equal to log of L of 0 plus NT. Okay. So the first expression can be written as E of T, where A of 0 and L of 0 are the initial values of the effectiveness of labor or the knowledge accumulation, as well as effectiveness of labor knowledge accumulation, as well as the labor force at the any time period equal to 0. So is nothing but E of G to the power T where E is nothing but the exponential function. So at any time period T, the stock of knowledge accumulation on the effectiveness of labor as well as the stock of the labor force employed will be nothing but given by this expression, where it will nothing but the product of the exponential E raised to the power gt multiplied by the initial stock of knowledge accumulation in the economy for the effectiveness of labor force at time period T. And for the labor force itself, it will be the exponential function, that is E of nt, E raised to the power n of t multiplied by the initial stock of labor in the economy at time t equal to 0. Okay. Now, as far as capital is concerned, so the output that is being produced can be used either for consumption and investment. So this is another assumption of the solo growth model, and it is totally exhausted. And whatever is being and for investment, we require savings. So part of the output will be saved, and the part of it will be consumed, and whatever is being saved will be used totally for investment purpose. So let us assume that the rate of savings of the output in the economy is given, which is one of the assumptions of the solo growth model, and it is fixed at S. Further, to keep the further, we also need to make certain investment. So this investment will include also the investment that we are making to make up for the wear and tear or the depreciation of the capital. So essentially, the rate of growth of capital then at time period T will be given as this following expression, which is nothing but the total savings in the economy minus the depreciation that has taken place at time period T for the capital stock. So at delta is nothing but the rate of depreciation of the capital stock. So now we can study the dynamics of this rate of growth of capital in terms of the dynamics of the rate of growth of capital per unit of effective labor over the time period. So we can now write this as follows, that is K is nothing but K by AL of T, so which can be again written as K dot T AT LT minus AT LT square. This is KT. So here we have got K dot T LT plus L dot T AT. Okay. So this can again be written as K dot T AT LT minus KT AT LT So we can now substitute all these values of K dot T and the terms in the bracket, that is K dot T is nothing but S of Y of T minus delta KT. This is A of T, N of T minus T. So this is nothing but the growth rate of the effectiveness of labor, which is G, and this is nothing but the growth rate of labor force, which is N. So we can write the numerator as follows, that is minus del plus N plus G of K of T. Now using these factors, that is nothing but Y as well as this, that is we can rewrite this expression as follows. That is f of k of t minus delta plus n plus g k of t. So this term, that is within bracket delta plus n plus g multiplied by the stock of capital per unit of effective labor at time period t is the break even investment. So this investment is required to keep the capital per unit of effective labor constant at every time period. So because of depreciation as well as the rate of growth of labor and the rate of growth of the knowledge of capital, so to keep that ratio from falling, that is small k, which is equal to capital K by AL, we need this minimal level of investment, which is a break-even investment. And f of k of t is nothing but the investment which we are making as a proportion s of the output per unit of effective labor. So effectively we can say that the growth of capital per unit of effective labor is nothing but the difference between the gross investment per unit of effective labor as well as the break-even investment which we require. Now when these two terms are cancelling each other out, then the rate of growth of capital per unit of effective labor will be 0, and hence there will be the ratio will become constant over time. If this expression is positive, that means if k dot t is greater than 0, that means the capital is now growing over and above the break-even rate, or the so and hence this k ratio is growing, that is small k ratio is growing, and if it is less than 0, that means the small k ratio is falling. But we all know that we wouldn't like that ratio to fall, so we will be investing only up to the point where k dot t is equal to 0. That means when the gross investment equalizes the break-even investment. So if we look at this graphically, then we can see this linear line will be representing my break-even investment. On the horizontal axis, I will be representing my level of capital per unit of effective labor, and this curve is representing my gross investment. Okay, so the intersection between the gross investment curve as well as the break-even investment curve will give me the optimal level of capital per unit of effective labor, or the optimal small k ratio. So this is nothing but my gross investment curve per unit of with respect to the as a proportion is of the output per unit of effective labor. So at this point, suppose this point the investment per unit of effective labor, investment in terms of output per unit of effective labor falls below the break-even investment, and hence the k ratio will actually be falling. So to prevent that, we only stop at that point where the gross investment is equal to the break-even investment. Okay. Now, once we have reached this point, that is where k star, my k dot t becomes 0, that means there will be no change in this ratio, that is k by L. So at this point the capital stock in the economy, that is the total capital stock will be given by this, that is L of k star. So beyond this optimal point, so once I have reached this point, the capital stock will be growing only at the rate of n plus g, which is nothing but the rate of growth of effective labor. So capital is also now growing at the rate of effective labor, and effective labor is growing at the rate of n plus g. So using the assumptions in the Solow growth model, output will also be growing at the same rate, that is n plus g, and hence output per unit of labor as well as capital per unit of labor will be growing at a constant rate of g, which is nothing but the rate of growth of the knowledge accumulation of the effectiveness of labor. So technically speaking, once you are reaching this point k star, which is the optimal ratio of capital per unit of effective labor following the intersection of the gross investment curve and the break-even investment curve, capital and labor as well as output will be growing at the rate of capital and output will be growing at the rate of growth of effective labor, which is nothing but N plus G, and the output as well as the capital per unit of labor will be growing at the rate of G, which is nothing but the rate of growth of the accumulation of the capital or the effectiveness of labor. Because of this constant growth rates, we will we say that after this optimal small k ratio has been reached, the economy will be following a balanced growth path because of this constant growth in all the variables that are used in the production function in the Solow growth model. So thank you for listening to this lecture on the Solow growth model, and I hope that you have enjoyed it. So thank you once again.